And what's been happening at a new station that's very exciting that he's built up in the northeast corner of Maine up near the Canadian border. But first, just a little bit about the multi class and contesting. As guys like K3LR and Frank Donovan, W3LPL are going to tell you, it's the most difficult and most challenging class in a DX contest. And there are good reasons for that. And there are significant barriers to entry. It may not be exactly the same in all cases, but let me break this down just a little bit for you. You need at least 11 stations, 2 on each band, 1 for 160 meters you can probably get away with. You need an operator team of usually at least 12 to 14 qualified people who blend well with each other, can check their egos at the door, and actually work as a team. You need an excellent set of antennas for the primary operators. You need an excellent antennas set of also for the secondary operators on each band, because most stations are set up with 2 radios, 2 operators going during their time of operation. You need to minimize interstation splash as much as possible, so if one station's transmitting, the other guy on your band can actually hear who's calling him. And you need to handle the logistics of the operation. In other words, if they're all on site, housing the operators and then feeding them for several days. That's what it amounts to. So all in all, it's a pretty big deal. It's much bigger than a bread box. Now, Krassy, for years, as long as I've known him, has dabbled in a number of contesting entry styles, but the one that he gravitated toward the most was multi-single. And Krassy is a firm believer in what I refer to and he refers to as the European model for multi-single. Well, what does that mean? Well, if you take a look at Echo Fox 8 radio, CN2AA, Papa 33 Whiskey, you're gonna find 2 run operators typically on the band, and you're going to find a number of secondary operators that we'll call in-band. And the idea is your run operators generate as high a total as they can per hour. And the in-band stations, if the interaction splash is low, can contribute materially to the hours that you're generating during the day. Sometimes as much as 80 to 100 additional contacts. So Krassy took a look at this and said, I like that model, and is there a way to apply this to the multi class? And his vision was basically, as I understand it, this. How much can I automate this station? How many operators can I put on a band at the same time? Can I bring remote operation into the mix? And can I build a station that is so flexible that I can turn it all around dynamically on a dime? Now, what does that mean? Well, the first time I saw this was in the 3rd iteration of what he's going to show you today, which was installed in 2017 over at JT5DX in the Gobi Desert in Mongolia. And I noticed that as soon as DX log, which was the logging platform, was changed, all the antennas switched automatically to that band, and they were all available with point and shoot technology, transmit and receive. And I said, wow, that's pretty special. I wonder if you can actually do that on all bands all the time, because that sets up an opportunity for what I saw as a layperson, because I'm not going to pretend to tell you that I even begin to understand the technological wizardry that Krassy's vision, as executed by Velimir Jarek, K3JO, who's the mastermind chief engineer behind everything you're going to see here today. It was Krassy's vision, but they built this all together. And I'm not going to begin to tell you that I fully understand it, but from a conceptual standpoint, I can look at it as the same as you will here shortly and say, this is very creative, and it offers some material advantage to the way I believe most multi-multi stations are probably designed today. And in order to help us understand that, I asked Krassy the first question, which was this: how many remote operators can we bring into this station? He said, as many as we have transmitters for, because we have a high-speed fiber Ethernet internet coming into the 1 gigabit coming into the station, and so that gives us very low latency, and we can handle all of this. The second question I asked him was, how many stations can we put on the band on a single band at any moment at the same time? He said, it's unlimited, as many as we have. And I said, well, if you can really do that, and if you can manage that environment dynamically, what I saw immediately was the following. Imagine, if you will, a station where you can do this. 20 meters opens shortly before sunrise up in Maine, sometimes a little earlier than that, and you put 5 operators on the band at the same time. Now think about that for a second. 15 meters opens at the same time, and you bring your nighttime operators, and you may have another 4 or 5 operators on the band at the same time. And so the strategy is that your run guys go like the wind, and your chase guys in band, they run around like rabbits chasing everything on the band map, everything coming in through skimmer, everything coming through the packet clusters, and the rate is just off the chart. Same thing on 10 meters. Now, I operated 160 meters, and as soon as I got an hour or two of sleep, I was right over there on 10 meters as one of the 4 or 5 guys that was helping KI6RRN, who happened to be in California, as one of the remote ops. And it was just, to me, very, very compelling. And so the dynamics of being able to move stuff around adds what I think is enormous capability to the multi-multi environment. And Krassy's going to show you how he and Velimir made this all happen. Now, I have to give credit to some other guys who I know are here in the room. For the last 8 years, as this was being built, Krassy's had Velimir being a one-man army. The guy runs around like a chicken with his head cut off because he understands the entire station better than anybody else. And he manages it every time there's a fire somewhere. But recently he's got some help. Now, sitting in front of me here, Manu, you might want to stand up for a second, is AC1ANU LU9ESD. He's recently been employed by Krassy, and now he helps manage this environment, especially when the fires happen. We lost 6, basically, of our remote stations on Saturday morning in the contest, and that meant we had, 6 operators that were down for about 45 minutes. Velimir and Manu managed to get it up on another model that was able to be used. And Velimir, you might just stand up for a second too, if you don't mind. This K3JO, who built everything you're going to see. Now, also on our team was the lead maintainer of something called DXlog. And Paul, K1XM, are you in the room? Well, yeah, okay. Well, Paul, sitting over there with KQ1F, was the guy who maintains DXlog, which was the logging platform that we use. And some of us were not familiar with DXlog. And so it's like, hey, Paul, how do I do this in DXlog? Well, an Alt-G on the computer to one of the guys on the team got your answer. So he was a very valuable addition on the team. Jerry, W1VE, are you here? I think he will. Yeah, Jerry, stand up if you will. Okay, Jerry is one of the most knowledgeable guys in terms of remote operation. And he acted as in a consulting capacity to help some of our guys who are in other sites come on board and understand, how they could be hooked into the station in a way that actually worked for them and for us. And some of our operators had basically never done remote operation until 4 days before the contest started. And that kind of assistance was more than valuable. I know Dennis, W1UE, you in the room? Dennis was one of our guys who worked with K1XM over on 80 meters. Mark, N50T, you here somewhere? Okay, he's in the back of the room. Mark lives in Oklahoma, and he came in remote and did 40 meters with Krassy. So that gives you the flavor of this. And I'm going to stop talking in just a second, but I'm going to tell you that Krassy Station is in 3 buildings spread out over about 60 acres up in Maine. And so what you are going to see takes place in not just one major operating room, it's in 3 operating theaters with 9 remote operators coming in from everywhere. And so it's a very powerful combination, and the vision actually, I think, has been successful. It's been proven to work, and Krassy gets a lot of credit for thinking about it, dreaming it up, and Velimir for actually making it happen. The one thing about remote operation that is very valuable too from a different perspective, you don't have to ask your team members to fly into Bangor Airport, rent a car, drive 2 hours up to Jonesboro, Maine, and then walk around in knee-deep snow and glare ice trying to get from building to building to be on your team, or drive into Boston Logan and drive 6 hours to get there. The other thing is with remote operation, the guys who really are good in multi operation are in high demand. K3LR has built a great team over the years, as has W3LPL. And what you can do is you can source operators from anywhere. If they're going to be remote, they have a fast enough internet speed, and somebody like Jerry can help them get connected to the system. So what you're going to see is a vision that took 8 years for Velimir and Krassy to develop. They took 9A5K's DXlog program. They overlaid something like thousands and thousands of lines of code. There are 1,200 relays in the system that Velimir designed to switch stuff around. And when it works, it's phenomenal. So anyway, I'm going to turn this over to Krassy. Krassy, take it away, please, my friend.
Well, for me, it's a big honor to have Jeff introducing what we did it. And I want to say thank you very much, Jeff, and thank you very much to everybody who was involved in this project. I started this project early. In 2005, I had an accident, so after my accident, I decided that I'm going to spend part of my fortune to contribute to the ham radio community. And for this, what happened is over the years, I built a bunch of stations to learn how to do a good one. So the first one we built in Jamaica, 6 Yankee 1 Victor. After this, we built Echo Delta 8 X-Ray in Tenerife. So this was a station which we putting up and down every time because we still have no permit, but the station is complete. Over there, we have a lot of equipment which is ready to be used for contesting. The next one was JT5DX. We built it in Mongolia for a friend of mine, Chuck. And next one was Lima Zulu 5 radio. Maybe many of you knows that contest station from Europe and results they have lately. And now we have K1LZ in Maine. And we started first with Ray, W2RE. We built it a remote station together. But there was a different approach from Ray, so we decided that he's going to go in his way and I go in my way. So I built the next one in Jonesboro, Maine. So in order to do that, the first thing we did is to study the terrain. And we studied the terrain pretty extensively, so to know how high the tower is supposed to be, how much spacing we have to be between Yagis. After this, we choose every single Yagi, and we tested every single Yagi, and which we're going to use. We tested at my place in Boston, and we build a station. Let me see if this can start. It's running. It says. We had a small video used by this is the young gentleman which is operating from our station. cluster of 6 towers for the running station. The towers are over 200 feet. And the reason we did that cluster is we have 2 sets of stacks for the beds. And that way the running guy can use diversity receiving in order to run maybe on, to listen into different direction or split the stacks on listening in different direction. Also, we have 3 more towers, which is located 800 feet from the main station, and we're using a lot of antennas there in order to do in-band. So building station like this, it's required, I'm gonna go through very fast through the history of building a different station. This is the 4 locations we built over the years. This is Lima Zulu 5 radio. There we have over there the 80-meter 2 for 3-element full-size Yagis on 80, and we have a lot of other antennas. This is during the building of this station in Bulgaria. This is how Lima Zulu 5 radio looks like inside. It's the same concept. We use the same concept here in US, but we're adding a lot of more remote capability. This is Jamaica. We did quite a bit history in Jamaica also. This is Echo Delta X3. Over there it's about 10 towers also with a lot of antennas. I think we had about 30 Yagis operate multi-single 4 times. But every time we have to take that station down. And taking all the knowledge, we're getting into Jonesboro. This is the cluster where we have the 6 towers. 3 of the towers, the only top antennas rotates, and the other 3 towers, the whole tower rotates, and they have, of course, stacks for all the bands. For example, one of the tower, which we're using mainly for Europe, this is 2 4-element 40 and 6 7-element 10 meter. This is another stack with 2 4-element 40 and 5 of the 7-element 10 meter. This is a 15-meter tower, which is have 4 Yagi. The top only rotates, and this is we're using mainly towards Europe. And the other one is the rotary tower, which is the same 4 6-element Yagis, but the whole rotates. So this is allowed the 2 running operators to have 2 different equal stacks in 2 different directions. 20 meter is the same thing, but only 3 antennas because the height. So this is a 208 feet towers, which is allows us to run Europe, and this is the only top antenna rotates. This one is the second rotary tower. Unfortunately, we didn't make a very good calculation with the guy wire, so the antennas are too long and we cannot rotate it. It's why it's unfinished. So, but supposed to have 3 6-element monobanders on 20 meters. So this is very interesting tanks. This is a huge 5-element 80 meter, which is have a very interesting approach designed by Velimir. We have a small box in the middle, which is contain only capacitors, so the antenna is tuned on CW, and with capacitors, switching different capacitors, we can tune each of the elements to participate on different frequency, from 3.5 to 3.8 megahertz. So we switching only the length of the antenna just by using capacitors here, and this was the engineer's design by Velimir. This is in-band towers. The in-band towers also have monobanders on different directions, plus the tri-banders on the top. It's I think a 16-element GXP antennas. This allowed us to have, for in-band, have two tri-banders plus the monobanders on different direction. One tower, the second tower is for tower number 8. It's the same, but with different directions on the antennas on the single banders. And the last one is 11-element tri-bander, which has allowed us to have 3 tri-banders for the in-band guys. So it's how the station looks like inside. We have 3 locations, and like Tom, he put in containers. This is also containers. And we have, right now we have 12 setups of radios, but our system allowed to use 18. So right now we have 6 FTD X101MP, 5 ICOM 7800, Flex 6600, 8 ACOM amplifiers, and 4 burst amplifier, but this is a Russian-built MOSFET amplifier. So, how the system is set up? Our system allowed us to put 18 radios and about unlimited amount of antennas, and each radio can have every single antenna you need it. So when we designed this thing, we designed it to the station to be able to work as a single op, SO2R, multi-single, multi-2, or multi-multi by just setting up the logging software. And when you set the logging software, that pre-configurations of the station immediately allowed you to do any mode without any changes anymore. And the reason this is possible to be made is each radio, let me move this thing closer to me. Each radio is directly connected to the X-Log, and through the filters and amplifiers, we go to the antenna selector, and the antenna selector is controlled by partially a software-hardware solution, which is called an antenna server. This has allowed us to switch all the antennas and all the interlock depend on the setup of the station, the way how we want it. So if it's a multi-single, you guys can imagine we can have 2 operators which is running the pile-up. They listening in 2 different directions, and we can have up to as many stations you have, as many antennas you have, in-band guys to do the in-band operation. So, this is the one aspect of the designing of the station, to be extremely flexible, to be able to use an ability to put lots of people in one band, depend of the situation of the condition. We control this thing with up to, we have 16 I/O boards, which is can be up to 128 boards, This is allowed us to, what happened? So right now we have 768 outputs, which is controlling about 1,500 relays in order to achieve what we want to do. This is how a typical screen looks like when you operate on, I took a screenshot of the 40-meter operation. On the top corner, you will see the antennas available for this band. And in the green color shows up that this is the antenna which has been selected. We can select RX and TX separately, so you can transmit with one antenna, but you can listen with any other one. So, for example, on 40 meters, we have 6 Yagis, 4 element, and we have 2 4-squares, and we have a bunch of receive antennas. So imagine a running guy can take one set of Yagis to run in one direction, and the other guy can run in the other direction. At the same time, we have another 2 Yagis for inbound guys to have inbound operation. Plus, we have 4 squares in order to add more operators in that band. So we had our situations which sometime on 10 meter we can have 1 running guy and 5, 6 inbound guys just working at the same time. It sounds very confusing because many people who is working a single op, they cannot handle when somebody else operate on the band at the same time. But this thing, after a lot of practice, it's working. And I can tell you guys this, without this ability, I believe today it's almost impossible to make scores like we're making these days. This is a typical setup for one radio. So the radio is connected with the DX lock here. We have a band decoder, which is allowed us to control the filters. And we're looking for each radio for 2 connections. One connection is inhibit signal and PTT, which we're sending to interlock antenna controller. After this, the antenna selector and antenna controller, all this stuff is calling antenna server. This is software hardware device, which is doing the interlock and doing at the same time antenna switching. This is a SO2R setup. SO2R setup contains 2 radios. You have SO2R box, the DX lock sitting on the bottom. After this, we have outputs to the network, and this is allowed the guy who is running SO2R, practically he have 2 antennas to each radio to do diversity or to listening in 2 different directions. This is a very good trick which we're using here because with the 2 radios, we're doing something like we're putting one of the signal on the different pitch and the other signal low pitch, the other signal is high pitch. This allows you to detect very well different pileup, because you practically, if you listening in 2 different directions, you can separate from where it's coming the signal. It's require a little bit practice. This is how a screen looks like for SO2R without any packet when you're doing single op without packet. A typical antenna switch, the antenna switch box have 12 inputs, 4 outputs, and this is how the antenna switch is designed. This is how the actual board looks like, and Velimir spent maybe 5 months to design that board, only to make sure they going to be minimum losses inside of that switching system. This is the heart of the antenna switching. And on the top left corner is the controllers, which is doing the input-outputs for the control system. This is our antenna server. On the left side is the antenna server. On the right side is the rotor control. So this shows up that we can control the rotations also automatically. It's something which shows up just one screen, the preset done for only 40 meters. This is presetting the path where the relays can be switched during the operation. So I want to go back to the main screen. All right. So imagine you're an operator. Doesn't matter you're a remote operator or you are on the site. This is how the screen is going to look like. On the bottom is the X-log logging. A little bit on the bottom corner, it's a small window which is turning red when the other if somebody is if somebody transmit. A little bit on the top, it's a partner window, and when we have 5-6 people listening and one guy running, these 5-6 people can fill up the partner window, and we have a small macro which we wrote it, and we can pick up the call sign from the partner window and directly answer it without even hear that guy because somebody else hear him. On the top left corner is the available antennas, and the antennas are available for receive and transmit. So imagine you can transmit on this antenna, which is the 4-element towards Europe, but you can receive on every of those on the left side. And this is with the stack. It's an example. For example, I can transmit on single antenna, but I can listen the entire stack. On the right corner is the amplifier. We develop also this thing with the help of some friend of mine. We develop a server for the ACOM 2000, which has allowed us to tune the amplifier and to see if we're transmitting. And this is concluding the whole station. Behind the design of that station, we try to maximize the score, not just on single op, multi-single, but we also, right now, our target is multi-multi. The last aspect of the design of the station is remote control. So the remote control, we're using any desk, and we're using all kinds of techniques. And we're testing every possible radio. So we start with flex. We have an old ICOM 7800, which we're running with RSBA1. Also, we're testing IESO with ACU LAN 10 unit. Also, Flex we tried with Smart SDR. Right now we will try also K4. We did it K3 first. So, but I can tell you, we still don't have a complete solution. But I think our solution is pretty good because we don't have any problem running remote and in the site. We don't experience any delay or something, which is many people complain about the remote control stations. And also the way how we did it, we bring into the remote site, we bring in digital audio. That way the pile-ups looks very good. It's not smeared by compression of the signals. In order to do PTT, we're using the Velimir. We transfer COM ports from the station to the remote site. It's just, I had a screenshot I operate last week from Germany airport on CQM contest, half an hour, and I make that shot just to show that I can operate from any place in the world. This is how my home looks like when I do SO2R with 2 FTDX 101 MP. Little picture. This is how the SO2R looks like at the place. This is how the stations looks like. And this is 2 operators operate. This is the inbound station. And that's it. Thank you very much for the time, but I would like to say thanks to everybody who helped me to do that.